Let us start. Let me share the screen for you. So last class we have seen how the analysis of T-beam is done and how the T-beam is distributed into two sections, majorly section 1 and 2, where the flange part and web part are divided in separate sections. And using those two parts, we can proceed our design. And we have seen, we have read the case where the neutral axis will fall within our flange. So that part we know that the whole section is considered as a rectangular section and with a width of that is equal to the width of flange BF. So that is the case, first case. And second case, the second case is that when the neutral axis is at the web part, means not it is not falling on the flange part, that is XCO is more than DF. So in that case we have actually divided our T-beam into two sections, two major parts. One part is a web consisting of width and some part of, and the width is width is the width of a web, that is BW, and the depth is taken as the effective depth, small d. And second part we have considered the flange part, is the width is equal to the total width flange of the web. So those two part we have considered. Those two part we have considered the case two. We can proceed our analysis, and from there we can get our values of XU and MU. So let us discuss about problem. So 80 system, that is for a slab system, is having 120 thick slab supported on beams. Okay, slab, the depth of slab uh, 300 mm. So BW is given and effective depth small d is given as 580 mm. The beam has reinforcement 8 number of bars, 20 mm dia, M20 grade concrete and Fe415 steel is used. The beams are spaced 3 mm. So the effective span we can also get from here. And the effective span of the beam is given as 3.6 meter. So given we have depth of flange is given. There is the thickness, slab depth. Width of beam is given, BW, and effective depth is given. Area of steel we can find out 8 number of bars, 20 mm. So with this, first step is we have to find out the effective width of flange, that is BF. So for this condition, that is for simply supported condition, we have as we have seen in our previous class that for the condition when for a T beam, that is for a simply supported condition for a beam, the value of BF is given as per IS code is L0 by 6 plus PW plus 6 DF. So using this, we can find the value of L0, okay, and that should be equal to 3.6 meter. Okay, that is since the effective span of the beam is given. So from here we can find the value of BF. So putting all the values, that is 1620. Next is to find the clear span of the slab. Okay. So to find this, the value of effective value of your thickness of the flange, the width of the flange, that will be dependent upon the value of that is given by the IS code clause number 23.12. So from here, this value should not be more than half of L1 plus L2 plus width of so this L1 and L2 are what? These are the clear span, clear span uh, between the beams, between two beams. So the distance is given. So the distance is 3 meter. Effective distance and rotational distance is given, and we know the width of the each beam. Width of each beam is 300 mm. So 3 meter minus 300 mm from both 300 by 2 from both sides. Okay, see 150 mm plus 150 mm. So here we get as 2700 the value of L1 and L2. Okay. So if you have seen the previous notes, if you remember, then you will be able to understand what are the distance, what are the values of L1 and L2. If you can visualize, and so from here, the value of BF is obtained by this way also. Next step is to find the value of neutral axis. So the neutral axis for this condition we know is 0.87 FYST by 0.36 FCKBF. Okay, so all the values are known, and finally we can consider the value of BF as 1620 mm. So from here we find that the value of XU is 77.8 mm, and this is less than the depth of the flange. Okay, so we can say that this neutral axis lies within the flange. So from here we know that the design will be considered as a rectangular beam, the width of the beam as BF, width of flange, right? So from table 4.2, as discussed, the value of X max by D for Fe415 steel is 0.48. So from here we can get the value of Xu max. So this Xu max is coming 278.4 mm. That is more than the, we can say that this is under reinforced. Okay. So finally, the moment of resistance is calculated by the formula of rectangular beam 0.87 Fy ast into D all multiplied by 1 minus 0 ast F. So since the width is similar to beam and since the width of that of the flange, so B becomes BF and all the values are known. So finally we can get our moment of resistance from this. Okay. Next, let us discuss another problem for a condition. So here the question is for an isolated simply supported beam. Okay, so for isolated simply supported T beam, the flange width is given is 2400 mm. Then the flange thickness means the depth DF is given, that is 120 mm. Effective span of the beam is given 3.6 meter. Effective depth of beam is 580, means value of D, and its width is given as 300 mm, means BW is given. And reinforcement values are given 8 numbers 20 mm dia bar, Fe415 steel, and grade of concrete is M20. So moment of resistance is to be calculated. So we know that since all the values are given, Fy, LFCK, AST you can find out, and the value of BW is given, D is given, DF is given, and B is given, the overall breadth. So for the isolated beam condition, we know that as per IS 456, the value of DF is L0 by whole divided by L0 by B plus 4 plus BW. So this is the condition for isolated beam, the value of BF, the width of flange. Okay, the effective width meter. So from here, you can value of so that is coming 9.54 mm. Okay, but the actual flange weight is considered as is given here is B, that is 2.4 meter. So that is much more than the value BF. Okay, so BF as 950 954.54. Okay, next step is to find the value of the depth of neutral axis. So the depth of neutral axis for the flange section is the same. The equation is same, 0.7 Fy ST by 0.6 FCK BF. So from here we get that this value is actually more than the depth of the flange. Depth of the flange thickness is given 150 mm, 120 mm. So it is coming more. So since as our assumption was that of considering this as neutral axis that is lying within the flange is wrong. Okay, so for this value that is more than the neutral axis, the depth of neutral axis is more than the depth of the flange, so it is where my depth of neutral axis is more than the flange, that is coming case number 2, XU is more than DF. So for this condition again I have to further check whether the values of the DF are within the range of 3 by 7th XU, less than 3 by 7th XU, or okay, as discussed in the previous class, we know why this has to be checked. So now here we can see that it is the case for DF more than 3 by 7th XU. Okay, so using the equation for this condition where case 2b, as discussed in the previous class, case 2b where the value of xu max is more than xu and more than df, and where the value of df by xu is more than 0.43, means 3 by 7th of xu. For this condition we can use the equation 5 as seen, that is 0.36 fck bw into xu plus 0.45 fck yf into bf plus bw. Okay, we have seen how yf determined. Okay, it is a factor that is obtained. That is, you can find this in para G 2.21 of IS code. Okay, and the value of YF is how much? 0.1F, 0.15 XU plus 0.65 DF. Okay, but should not be greater than DF. So, putting all this value, we can determine the unknown, that is YF. Okay. So, as you can see, uh, so from here, from this equation, by putting this value of YF in terms of XU, we obtain the value of XU ultimately. So when we check now, the 3/7 of XU value, that is less than DF. So hence we can say that the assumption that we have considered, that the DF is more than 3 by 7 is okay. Okay, so we can proceed. So now we can find out the actual value of YF from here, and whether it is under enforced or over enforced. So from the value of xu max by d, that is 0.48, we can obtain xu max value. So xu max is more than xu, so it is under enforced. And the corresponding 109.46 mm. Step is to find out the moment of resistance. So for this condition, we have seen the value of mu that is to be obtained. That is from equation 6 as discussed in the previous class. That is mu is 0.36 fck bw into xu into whole multiplied by d minus 0.42 xu, and it is also a factor of yf, so plus 0.45 fck yf into bf minus bw whole multiplied by d minus yf by 2. Okay, we have already seen how this equation is coming. Okay, I hope there is no doubt with anyone how this equation is coming and why so. If you have understood the previous class, you will know why this equation is coming and how it is coming. I have sent the notes of this previous class. I hope all of you have received it. So after finding out all the values, equating all the values, we will get the value of moment of resistance from here. Okay, so can you solve this type of problem? You just consider the same problem, and only you consider the value of reinforcement. Instead of 8 bar, you consider instead of 20 bar, you consider 25 bar. Instead of 8 number of bar, you consider 10 number of bars. So 10 number of bars, 25 dia. Means for over reinforced section. So can you just find out? Can you check out? Or if you try to solve this, first you find the value of AST, 12 number of bar, 25 dia. Sorry, 10 number of bars, 25 dia. So just solve this example 2 with the reinforcement value 10 numbers of dia, 25 and check how much the moment of resistance is coming. For if when you consider a values remaining same. Okay, consider this equation 2. Question number example 2 that I have difference is dia consider 10 and dia consider 25 10 numbers per. Example 2. For example 2, only consider the all the values same, only consider a number of bars 25 dia. And just solve the problem. Check how much moment of resistance is coming and tell me the answer. So here actually what will happen, the value of AST will change and other things will remain the same. Okay, value of BF already you have obtained, so it won't change, it will remain same, that is 954.54, and then you calculate the value of XU from here. It is over enforced. So since we have already considered the neutral axis which is falling in the flange to find out the value of XU, you will see that the value of XU is coming more the depth of than the depth of flange. So the assumption will be wrong. So now next step is to check the second case, that is the value of TF is less than 3/7 XU. Okay, so earlier case we have considered DF more than 3/7 XU. This time you will consider DF less than 3/7 XU. Okay, and from there, from that case, we will consider the equation 3 of the DF by X is less than 7 XU, that is 0.43 XU. So for this, what will happen? The total compression will be from the rectangular stress block portion of the flange. Okay, the entire flange will be having the rectangular stress block portion. So total compression is 0.3 FCK BW into XU plus 0.446 FCK whole multiplied by BF minus BW into DF. And the value of total tension, it will remain same as 0.87 FY AST. So using this equation that I just told, you have to find out XU. Okay, all of you have written this example. Example number 2. How much is the value of XU coming? Try to solve the value of XU, and for considering the value of DF less than 0.37 XU, you check this whether your assumption, you consider the second case A, that is DF is less than 0.43 XU.
पीपीटी नहीं दिख रहा है.
You write in the chat box. I'm unable to hear actually. I think it is raining here. I don't know how it will affect the network condition. No one is solving. Abhishek, are you there? Abhishek, Ritik Kumar, Ayan Chakraborty, Anuj Kumar, Abhishek Kumar, Jishu Shah, Mondal, Priyanka Bharti, Shah, Priyanka Kumari Chauhan, Divakar Chakraborty, Supratim Mukherjee. Anyone, are you present there, or you have just written the roll number and left?
Yes sir, present sir. Network issue sir. বৃষ্টি হচ্ছে এখানে খুব.
Okay, Ayan. So try to solve the problem that I have given. Example 2.
কথাটা কেটে কেটে যাচ্ছে.
Okay. All of you try to solve the problem. Example 2. It's raining here. All of you try to solve example 2. I'm again presenting the screen. All of you note down the example 2 and write it, and only consider the reinforcement as 10 numbers 25 dia. Means we are considering over reinforced section. For that you check how much moment of resistance is coming. Initially you consider the neutral axis is within flange condition. For that condition you check whether the XU is lying within the flange or not. It will not lie. Okay. So next is step is to that you consider the case 2 subcase A. Case 2 the value of dA by XU is less than 0.43 XU. Okay, means that the flange part will having the full rectangular stress block portion. So for that condition, the equation you, and for that you find the, it is the same way as done in the previous as done in the example 2. F will be same with the value of condition of dF by XU, where you consider as less than 3 by 7 XU. So here YF factor won't be there since we are considering the flange part is fully rectangular, so YF part won't be there. So without YF part, you have to do the calculation for finding out XU. Equation will remain the same, only YF part won't be there. So it would be 0.45 FCK into BF minus BW into DF. So instead of YF, you will write DF. And directly obtain the value of XU. And check whether the value of 0.43 XU is more than DF or not. If it is more than, then your assumption is correct. Otherwise, choose another option, another sub case. Then the remaining steps are same. All of chat box. Follow the chat box for instruction. Sharing the screen for example 2. All of you write, note it down. Note down the example 2. All of you resolve example 2 with changed value of reinforcement. That is 10 numbers 25 mm bar. Show me the value of XU, how much it is coming, and also the value of XU, whether the value of 0.43 XU is coming more than or less than DF, that you check to conclude that the assumption that you are considering is right or wrong. All of you try to solve in the piece of paper. I hope you all of you are having calculator. Just calculate it and give me the number. That's all you have to do. XU, find the value of XU, then check whether the assumption that you have considered that 0.43 XU is less than DF, that you check whether it is coming, that is 0.4, that you check whether it is coming or not. I'm waiting for your response. All of you try to solve this and give me the value of XU. Okay, I'm giving another problem. All of you try to solve that also. I'm writing in the chat box the problem. See, I have posted a question in chat box. All of you try to solve it. First of all, you find the value of the limiting depth of neutral axis. That is a XU limit. Okay. And after that, by D ratio, whether it is less than 0.2 or not. And then you find the value of YF from there. And from there, you can find the MU limit value. Okay, all of you write your name and roll number for today's attendance. That's all for today. Those who have not written the name and roll number, they write. Try to solve this problem at your home. If you feel any difficulty, you consult me.